At dawn on March 12, 1944, the air over Braunschweig, Germany, trembled with the rumble of distant engines. Cold mist clung to the roofs, and soot drifted from the chimneys of factories already running overtime for the Reich. In a reinforced hangar on the edge of the airfield, a group of Luftwaffe engineers gathered around a captured American fighter. An aircraft dragged from a crash site, scarred by flak, its wings cracked, its belly torn open, but its engine astonishingly intact. The men stood in silence as the giant radial engine loomed over them, its metal still smelling faintly of burned oil and high-octane fuel. For hours they had heard rumors about this machine, whispers that it shrugged off cannon hits and returned home when any German fighter would have fallen blazing into the fields. Now they were seeing the source of that mystery. Luftwaffe Technical Office Memorandum, March 1944. The hangar lights flickered as the engineers began unbolting the cowling. Tools clattered, steel scraped, and the thick plates finally cracked open to reveal the beating heart of the American juggernaut. The Pratt & Whitney R-2800 Double Wasp, a 2,000 horsepower radial monster, sat before them like something forged in a nation of endless steel and limitless factories. One engineer exhaled sharply and whispered, "Das ist kein Motor, das ist ein Geberge." This is not an engine. This is a mountain. Bundesarchiv, Engineer Diary. Outside, the morning sky vibrated again. Another formation passing overhead, another long trail of vapor steaming across the heavens. The engineers glanced upward, and one muttered bitterly that no matter how many they shot down, more came the next day. The Americans seemed able to replace losses without slowing for breath. That unsettling truth became even clearer when the senior inspector stepped forward, carrying fresh intelligence reports. In the dim light, he read the number aloud. 15,683 are 2,800 engines produced so far, with more rolling out of factories every week. The German team froze. 15,000 more? Behind this single engine? The figure felt impossible. It felt like industrial war on a scale they could scarcely imagine. U.S. War Production Statistics, 1944. As the investigation continued, the hangar filled with the rhythm of metal tapping, pencils scratching, and heated whispered debates. They examined every cylinder, every cooling fin, every baffling chunk of armor shielding the fuel lines. The deeper they looked, the more the mystery grew. Why did this fighter, designated P-47 Thunderbolt, survive hits that would have torn a Bf 109 to pieces? Why did its pilots boast of diving like a falling meteor, climbing like a locomotive on wings, and firing 8.50 caliber guns without the engine ever choking or stalling? German intelligence had believed the Americans fielded the P-47 in limited numbers. Now they were staring at proof that a tidal wave of them was already forming far beyond Germany's skies. U.S. Army Air Forces Intelligence Summary, February 1944. To understand how this moment in the hangar came to be, the story must shift back to the broader war, a continent-sized battlefield reshaped by steel, doctrine, and desperation. It was now 1944, the year Germany's strategic situation began to buckle under the weight of relentless Allied assault. The Luftwaffe, once feared, was stretched beyond its limits. Fighter groups that once ruled the air over Europe had dwindled to understrength formations, sometimes flying with barely half their aircraft operational. Fuel shortages, accelerated pilot losses, and the increasing dominance of Allied escort fighters turned every mission into a gamble. Reich Air Ministry Situation Report, January 1944. Meanwhile, across the Atlantic, American industry had reached a level of output that defied traditional military logic. The United States was fielding hundreds of aircraft every month, rushing fresh pilots through training schools filled with new airframes, and shipping engines, wings, fuselages, and spare parts across oceans with mechanical precision. Detroit, Chicago, Hartford, and Buffalo roared like connected furnaces. Some months saw the production of 1,000 engines, more than some countries produced in an entire year. Engineers like Frederick Rentschler, Leonard Hobbs, and the teams at Pratt & Whitney had created a machine that married brute horsepower with near-bulletproof reliability, something that stunned even veteran German mechanics. U.S. Aviation Manufacturing Review, 1943. The doctrinal clash was equally severe. German fighter design emphasized agility, climb rates, and precision engineering, aircraft meant to duel in lean, elegant combat. The American philosophy, shaped by vast distance and industrial might, favored something different: survivability, firepower, and endurance. The P-47 embodied that doctrine in metal. It was enormous, weighing almost 8 tons fully loaded, dwarfing the sleek Bf-109. Many German pilots initially dismissed it as a clumsy brute. But once the bombing campaign intensified, they learned, sometimes fatally, that the Thunderbolt's dive speed, brutal firepower, and armored resilience made it a nightmare to attack. RAF Fighter Command Comparative Analysis, 1944. And so, on this cold morning in Braunschweig, all those doctrines, philosophies, and industrial contrasts converged around the dissected R-2800. The German engineers, loyal craftsmen who had given everything to keep their fighters in the sky, realized that they were confronting not just a machine, but a national strategy built on overwhelming infrastructure. No matter how many breakthroughs they achieved, they were facing an opponent whose factories could erase their victories by the thousands. The senior inspector placed one hand on the radial engine, feeling the ridged surface of a cooling fin still speckled with dried mud from the crash landing. When Diocese Ding Offstedt, he murmured, "Stehen tausend im IT mouth. If this thing rises, thousands rise with it." Bundesarchiv, dramatized composite. Yet the true shock was still coming. For the engine itself, enormous and advanced as it was, told only half the story. The deeper truth, the advantage that would soon reshape air combat across Western Europe, lay hidden in the systems built around it, the supply chains feeding it, and the technologies layered behind its roar. What the engineers would uncover next would change their understanding of the American war machine entirely. And it would arrive not in a hangar, but on a battlefield where everything they knew about air superiority was about to be shattered. The truth behind the Thunderbolt's terrifying resilience did not lie solely in the massive R-2800 sitting on the hangar floor. What the German engineers lacked, and what their superiors did not yet understand, was that this engine was only the first link in a chain of hidden advantages the Americans had refined long before the first P-47 ever crossed the channel. It began with design philosophy, continued through engineering innovation, and ended in a colossal supply system operating far beyond the reach of German bombers. The engine was merely the most visible symbol of an industrial ecosystem Germany could not match. Technical Intelligence Bulletin, April 1944. The first revelation came when they examined the engine's dual magneto ignition system, redundant, rugged, and astonishingly resistant to battle damage. Each cylinder had 2 spark plugs, fed by isolated wiring networks protected behind armor plating. A German mechanic shook his head. A single 20mm hit that would darken a Daimler-Benz inline engine might barely inconvenience the double wasp. American engineers like Leonard Hobbs had insisted on multi-layered survivability, designing with the expectation that the aircraft would take hits and keep flying. This philosophy ran counter to the Luftwaffe's lightweight optimization. The contrast baffled the team. Technical Manual TM9 to 2800, 1943. Next came the induction system, an intricate maze of supercharger ducts, intercoolers, and pressure valves housed deep in the fuselage of the P-47. The Germans were stunned to discover that the Thunderbolt carried a turbo supercharger the size of a small motorcycle engine tucked far behind the cockpit. Driven by exhaust gases and regulated by automatic controls, it allowed the aircraft to maintain full power even at 30,000 feet, a height where Luftwaffe fighters often gasped for oxygen. The realization hit hard. The P-47 could climb into rarefied air, dive like a falling anvil, and still maintain power where German engines faltered. Bureau of Aeronautics Engineering Report, 1943. They traced the air ducts snaking through the fuselage, measuring their length and diameter. Each carefully curved channel reduced turbulence and heat loss, details that required advanced tooling and extensive factory space to manufacture. This was no field expedient design. It was the product of massive industrial coordination at Pratt & Whitney, General Electric, and Republic Aviation. One German engineer scribbled in frustration that such complexity was insanely wasteful. But another corrected him. The Americans had the luxury to build complicated machines because they had the factories to supply them. General Electric Turbo Division Report, 1944. Then came the structural shock. The airplane was built around the engine like a fortress. 8 primary bulkheads supported the fuselage. Fuel lines were shielded with armor. Control cables were routed low and deep to avoid gunfire. Even the oil system had shock absorbers. The aircraft could lose cylinders, take hits in the wings, and still bring the pilot home. Many did, limping, smoking, but alive. German pilots had reported the horrifying sight of damaged P-47s refusing to fall, diving away at unbelievable speeds. Now the engineers understood why. U.S. Army Air Force's Damage Assessment, 1944. But the heart of Section 2's mystery, the secret advantage, was not merely durability or horsepower. It was scale. The Americans could afford to produce weapons like this because their supply chain had no ceiling. Beneath every P-47 engine lay the unspoken truth. Hundreds more engines sat in crates, thousands more waited at depots, and tens of thousands more stood ready on production lines that never slept. This was the industrial war Germany could never win. U.S. Army Service Forces Logistics Summary, 1944. That truth exploded into deadly clarity on February 20th, 1944, the first day of the campaign that Allied planners called Big Week. As dawn broke across Europe, American bomb groups roared towards central Germany, escorted by the very fighters whose engines the engineers now studied. This was no ordinary mission. It was a deliberate assault on the Luftwaffe itself. The P-47s, flying from bases in England, spearheaded escort formations alongside the newer P-51s. Their orders were devastatingly simple: protect the bombers, hunt enemy fighters, and bleed the Luftwaffe dry. 8 Fighter Command Operations Log, February 1944. The sky over Oschersleben and Gotha erupted into chaos shortly after noon. Jagdgeschwader 1 and 54 scrambled to intercept, climbing through thinning air where their engines strained. The Americans arrived in layered formations, radios crackling, engines thundering. At 27,000 feet, a swarm of P-47s dove like falling meteors into the German interceptors, their turbo-supercharged engines maintaining power throughout the plunge. German pilots later described the sound of their arrival as a hammer thrown from the heavens. Luftwaffe Combat Report, February 1944. Machine gun fire stitched across the sky. The Thunderbolts fired their 8.50 caliber guns in devastating bursts, more than 13 pounds of lead per second. One German pilot reported watching a comrade's Bf-109 explode under the barrage before he could complete a turn. Others attempted to dive away, but the P-47s followed, accelerating past 500 miles per hour in near-vertical descents. No German fighter could match such dives. Their engines oversped, their wings shuddered, their control surfaces screamed. U.S. Strategic Bombing Survey, 1946. On the ground, Luftwaffe controllers watched helplessly as their fighters fell in ones, twos, and clusters. By the end of the day, American forces had lost bombers and fighters, but Germany had lost something far more irreplaceable: over 350 aircraft and dozens of veteran pilots. Factories could be rebuilt. Pilot experience could not. German commanders wrote grimly that the Allies seemed to have infinite aircraft. It was not far from the truth. Reich Air Ministry Loss Register, February 1944. In the midst of the carnage, one Thunderbolt squadron, the 56 Fighter Group, led by aces like Francis Gabreski, carved through enemy formations with clinical precision.